So the first type of word problems that we're going to do are distance, speed, and time questions. So we did this before in 7.4 about setting up a chart with distance, speed, and time and entering the data we know. Somewhere in there we have to choose a variable and then complete the chart with our formula. Should I move up a little bit so you want to write this down for the distance, speed, time questions? I'll move it right up and then I can read the question and then I'll move it down after. So Mario drove from Edmonton to Grande Prairie and back, a distance of 360 kilometers both ways. So in our chart, we can already fill in 360 kilometers here, 360 kilometers there. Mario's average speed was 30 kilometers per hour greater on his return trip than his trip out. So the average speed on his trip out is something we don't know, so that's where we can choose a variable. And we know on the way back it was 30 kilometers per hour greater, so we can write x plus 30 in there. Now for the time, once you've chosen a variable, we also don't know the time, okay? His total driving time was 10 hours, but we don't know the time for each one. That's where these formulas come into play. And this is the formula that I think is the easiest to remember because you know that speed is kilometers per hour, which is a distance over a time. And from that, we can rearrange each of these formulas and get. So for time, time is distance over speed. I would know from Edmonton to Grande Prairie, the time should be 360 over x. And from Grande Prairie to Edmonton, now it'll be 360 over x plus 30. Once you've figured out your chart, there's going to be something in the question that lets you write an equation. So if we go back to the question, I'm going to take out my highlighter, and I'm going to highlight the part that gives you the idea for writing the equation. His total driving time was 10 hours. In our chart, we have separate driving times. This is how much time it took here. This is how much time it took there. If I know the total is 10 hours, that lets me set up the following equation. That 360 over x plus 360 over x plus 30 has to equal 10. And now, how do we solve rational equations? We get a common denominator for everything first. So x plus 30, and 1. This one needs the x plus 30. This one needs an x, and this one needs an x and an x plus 30. And once you get that common denominator, the next step would be to multiply by that common denominator, which would just cancel out all those denominators. Now the numbers in this question aren't the nicest. We have 360x plus 30 times 360, so we'll do that. Plus 360x equals, and if I multiply this out, I'm going to get 10x squared and 10x plus 300x. Notice it makes a quadratic equation. How do we solve a quadratic equation? We make one side equal to 0. Personally, I would make this side equal to 0 because my 10x squared is positive on the right-hand side. So if I combine my like terms, 360 plus 360 would be 720x. Move it to the other side, I get negative 420x. And I move currently, that looks like it's hard to factor. You might notice there's a common factor of 10. You can either factor out the common factor of 10, or because it's an equation, what you do to one side, you do to the other side. So you could divide both sides by 10. And I would probably, I don't know, how good is your times table once you get up to 1,080? Do you know two things that multiply to 1,080 besides 1,081? Probably not. So most likely, at this point, I would recommend for you guys the quadratic formula. It does factor nice. 60 times 18 is 1,080. And if you made the 60 negative and the 18 positive, you would get answers of x equals 60 and x equals negative 18. However, in the context of this question, what was x? X is your speed. You can't be going negative 18 kilometers per hour. You'd be going in the wrong direction. You would never get there. So x equals 60 is the only answer. I would probably recommend the quadratic formula. What? Determine Mario's average speeds on each leg from, let's look at our chart. First we went Edmonton to Grande Prairie. That one was 60 kilometers per hour. And then Grande Prairie back to Edmonton. That one would be plus 30, which would be 90 kilometers per hour. And you can also take your answers and double check things. Like, can you see that if I plug in 60 for x, this would be 6 hours? 360 divided by 6. And if you put 60 in here, this would be 90. 360 divided by 90 would be 4 hours. Does it add up to 10 hours? It does. So things are matching up for us. So we can double check our answers to see if they make sense within the equation. So this would definitely be on a calculator part because you would use your quadratic formula and it has very big numbers for multiplying. Okay? It is factorable. Usually the ones that they'll give you will be ones you can factor. So let's do this one together. They like water ones where it goes upstream and downstream. So we set up a chart with distance, speed, and time. And we're going upstream and downstream. A boat travels at an average speed of 15 kilometers in still water. The boat travels 12 kilometers downstream, so we can put in, we know the distance downstream is 12 kilometers. In the same time, it travels 8 kilometers upstream. We need to find the average speed of the current. If you go 15 kilometers per hour when the water is still, would you be going faster or slower because of the current when you're going upstream? Slower. So if we make x our current, does it make sense that you would go 15 and then the current would, like if the current was 5 kilometers per hour, Against you, you'd be going 10 kilometers. And then when you're going downstream, the current is with you. This would be 15 plus x. So again, we have to choose something for our variable. We want to find the current. So it makes sense that we would put x as the current. And then we have to think, well, how does that affect your speed? Your speed was normally 15. The current's going to make it slower when it's upstream. It's going to make it faster when you're downstream. And then again, rearranging our formulas, time is distance over speed. So I can say my time here would be 8 over 15 minus x, and my time here would be 12 over 15 plus x. Once you've completed your chart, there has to be something in the question that lets you set up the equation. I'm going to take out my highlighter. I'm going to look through here, and I'm like, ooh, here it is. It's the same time, upstream and downstream. That means this one, when I write my equation now, I know that this one has to equal this one. Okay? How do we solve rational equations? We get our common denominator. So this one's missing the 15 plus x, 15 plus x. This one's missing the 15 minus x, and 15 minus x. I would probably make sure that these are in brackets as a single factor. And once you get that common denominator, you can multiply both sides by that common denominator. And those both simplify away. And what do I get? 8 times 15, 120 plus 8x equals 12 times 15. No, 8 times, yeah. No, this is not good math here. What did I do wrong? Is that also? That's 12 times 15. What's 8 times 15 is 120? Yeah, okay. That's 180 minus 12x. This could be done without a calculator. If I move the 12x to this side, I would get 20x. If I move the 120 to this side, I'd get 60. And because it's a word problem, you have to include all of our units. Probably good to write a sentence at the end. The current is 3 kilometers per hour. Circle 8, 11, 12, and 13. And these are your practice questions for distance, speed, and time questions.